Okay, welcome to this lesson on wave interference. Okay, and wave interference is when we have a wave, there's our wave, and we have another wave messing in with this wave. What is going to happen to the as a result? Okay, so it is quite helpful to imagine water waves. So let's just imagine a water wave and looking like that, and imagine a particle on that water wave. There he is. Okay, and it's a transverse wave, but it doesn't matter, it's longitudinal or transverse. Okay, but this is a starting position. If the water wasn't in waves, then it would have been quite calm like that, maybe not askew, but more or less. So that's where he starts, but because of the wave's motion, next moment it is there, it is displacing, and then it's there, and after a little while he'll be down. Okay, he'll be down there. Okay, so he's just moving up and down as this wave passes through. Now, what is going to happen if we have another wave coming around? Okay, so now we have the yellow wave coming as well, and let's say that's the yellow wave, and it's a different wave. It's not the same pulse that the first one had. This is a different wave. Now, while he's there at his starting position, this wave suggests he should be down here. Okay, so what's going to happen is that this part of the displacement, so now he has no displacement. Okay, and according to this one says no, he should have had negative displacement to the bottom. So he'll actually now be there. If we go to different position, okay, let's say we go to that position there. Okay, according to the first wave he should be down here, but according to the yellow wave he should be up there. So we have a displacement downwards, and the second displacement forces him upwards, and let's say it's more or less the same amount. Then the result will be that he will be there in the middle. Okay, and let's look at this spot. Okay, this spot right here. In this spot there's a downward displacement, and there's another downward displacement both by the blue wave as well as by the yellow wave. There's two downwards displacements, so in the end he'll be there. So the result of these two waves will cause a new wave. These two waves will interfere with each other and cause a new wave. So we have 1 point there, 1 point there, and 1 point there. I don't know what the new wave is going to look like. Very often these waves, like here, you see this will again be double the height. Okay, so new waves can be very complex. Okay, it's not necessarily this perfect sinoid graph. Okay, but the point is there's a new wave. It will have a new period, a new frequency, all depending on how these two waves interact with each other. Now there's just two words that we need to now understand. The first one is superpositioning. Superpositioning, it's actually a principle. The principle of superpositioning is that when two waves interact, the resultant wave, in other words, what happens to all of the particles as a result, the resultant wave is the sum of the displacement. Of the two separate waves. Okay, so that's just what I've been showing you, that the result is by adding the displacement that is suggested by the one wave with the displacement suggested by the other wave. Okay, so that's the principle of superpositioning. Something that I didn't mention here that's actually quite important is when two waves interact or actually travel in the same medium. Okay, travel in the same medium. That's when they will interact. If they don't travel in the same medium, they won't interact. Okay, so when two waves travel in the same medium, they interact, and the resultant wave is the sum of the displacement of the two separate waves. I never finished that. Two separate waves. Okay, so next up is interference. Okay, the word interference. Interference is simply what happens. Okay, interference is what happens when two or more waves travels in the same medium. Okay, in other words, through the air or through water or through space, whatever, in the same medium at the same time, of course, at the same time, resulting in superpositioning. In other words, these waves causing higher peaks and lower troughs, or whatever type of superpositioning of the waves occur. Okay, now there's two special types of interference that we are going to look at. We are going to look at constructive interference. Okay, and what does that mean to you? Constructive, obviously, hopefully you understand that construct means to build up or to make larger. So constructive interference happens when we have two waves. Here's my yellow wave and blue wave. Okay, so let me draw my blue wave with dots instead of, okay. And one thing that you notice about this is that all of the properties of these two waves are exactly the same, so that at each point the particle at every point is being emphasized by the one and the other wave. So for example, at this point, this particle right at the top, let me change my colors again so I don't, there is the yellow one's displacement and there is the blue one's displacement, all working at the same time. So we notice the resultant wave would be double the original wave. So peaks will be twice as high and troughs will be twice as low. Okay, so sorry for the ugly sketch, but I'm sure you see what I mean. So if one wave travels on top of another wave and that wave is in, this is what we call in phase, when two waves like that are traveling at the same rate and reach the trough at the same the trough at the same time and the peak at the same time, it's called in phase wave. Now when two waves are in phase is if one wave travels on top of another wave, this is what's going to happen. The waves are just going to be bigger. Now that is constructive. The other one is destructive interference. Destructive interference. So we get constructive interference and destructive interference. So here's my yellow wave. Okay, and let's fix that a bit. And here's my blue wave. And now you see the opposite happening. Sorry, I'm trying. Okay, where they are exactly the same, but when this one reaches his peak, this one reaches his trough. So that is the middle, and this is the displacement downwards, and that's the displacement upwards, and they cancel each other out. And that's what we have in the end, is that the resultant wave is in fact not a wave at all, and these are out of phase waves. Okay, so if I had to summarize all of this in a sentence, I would say when waves are in phase, okay, when waves are in phase, they're superpositioning, in other words, adding the waves, adding the waves, amplifies. Remember, we talk about amplitude is how high it goes above its starting position. So amplify means it increases that. It amplifies the resultant wave and is called and causes causes constructive interference. Okay, now for destructive interference, I will say when waves are out of phase, when waves are out of phase. Okay, so remember what out of phase mean: when the one is at its peak, the other one is at its trough. Okay, they're superpositioning I'm actually don't know what word to use. Let's just say destroy. Okay, destroys. How's that? Destroys the amplitude of the resultant wave, and causes destructive interference. Does that make sense? And there we see the resultant wave is the one in the pink. Constructive makes it larger, and destructive makes it destroys completely any type of wave that there used to be. This can very clearly be seen in water. If we have water pass through in a ripple tank, and we put two, so here's waves of water coming through. Let me make these a different color. Okay, one thing that you'll notice is that the water waves, even though they are these parallel lines, start doing this once it goes through the slit. Okay, well, that's an ugly one. Once it goes through the slit, and the same on this side. Okay, it does this. Now at these points the waves are in phase. Okay, at those points the waves are in phase, and here at points like this, okay, in the middle of these two lines but on top of the other one, they're out of phase. And what you'll notice there is that I can almost take the eraser here, that there are no waves at this point. At this point there will be no waves. Okay, and where else would that be? Somewhere like well, I can't find many of it here now, but I'll show you a video later on where you would clearly see this when we actually do the experiment, on how the waves that come through at this point interact with the waves at these points, and you can clearly see where the waves get larger and where they actually cancel each other out completely. But that in a later video. Thank you for watching this one. I'll see you in the next one.